able to do it, Kishan? Were you able to do it, Kishan? Okay, Kishan, it's okay if you researched also. I'll just. Yes, anyone else tried to do the pre-order, in order, and post-order code? Guys, be responsive. I cannot see your messages. Even if you're responding, I can't see it. No, okay. Okay, let's start with the pre-order. So since you know you need to print your traversal, so its return type is gonna be void. And for pre-order, I'll just write it as pre-order. And you will be having the root node. Or always, whenever you are traversing in a tree, you will be provided with the root node, and then you can do whatever operations you want to do. Clear? It's okay, Vishnu. So in the pre-order, what you were doing, you first need to call the left subtree, right? So for that, simply write pre-order and call for root dot left. So it is going to call your left subtree. Clear? After calling the pre-order, the next thing you need to do is to print the data. So you need to write here print root dot data. Clear, everyone? And after that, you need to call the right subtree. So again, you will call this pre-order function on root dot right. Clear? So it's very simple. You know that the nested calling is happening. So obviously the recursion is going to be used. Next, when you know that you should stop it, can anyone tell me what should be the base condition to stop it? Correct. If at any point your root becomes null, at that point you should return. Clear, everyone? Is it clear or is it unclear? Okay. Can I expect you all to write the code for in order and post order quickly now? Like it will hardly take you a minute or two. Just quickly write it down on your notes or whatever you are having right now, and then we will progress. I can see Bhuvnesh has sent me the code for, I guess, post order. Okay. As well as in order. Good, Bhuvnesh.
Ma'am, are you looking for the answer or just the code? Like, uh,
The code, like I have written the code for the pre-order, right? So I want you all to write the code for in order as well as the post order. Are you getting me? Vishnu, are you getting me?
yes, yes, absolutely. I got
Okay.
it.
Okay, then it's great. Anyone else who has any doubts? Otherwise, we will move further. Okay. So now our next concern is to find out the size of a tree. Size is nothing but you can say the number of nodes present in a tree. Our next function is going to be in size. You will be given.
And one question I have is the output of in order. Will it be 312 or will it be 317? First three
Just a minute. For which post order or pre-order?
in order. Second
Huh?
one.
In order.
Mm.
So it will be 3. Then it will go to the left. It will print the data again. So 1. Again, it will go to the left. Again, print the data first. So 7. So it's gonna be like, I'll quickly write the answers to it. This is for pre. For in, it's gonna be 3, 1, 7. Then it's gonna explode the left, like right hand side, so 5. After that, it's gonna be 2, 6, 8, 17, minus 6, 9, minus 1, 14, 19, and 3. If anyone would have, like any one of you has find out the answer, these are the answers. Should I write for the post as well?
Yes.
Okay, so it's like LDR. So no, it's L, R, and D. So you will go to the left, extreme left, and you're gonna print 7. Then you will go to 1, and first you're gonna print 5. Both are done, then 1. Then you go to 3, then 2, 6, 8, 17 will print first. Then minus 6, 8, then 9, then 6. All these done, then it will go to,
Minus 1, 2.
no, it's 19, 14, 3, minus 1, and 2. No, Kishan, I guess 3 is not gonna come in the last. You have the code, you have the data, you can take these data and try to print it.
Okay.
3 has already come, right? Like after 14, see, first it printed 19, right hand side there is nothing, then it printed 14. Then here when it went after 14, it first will print 3. Oh, okay, my bad. 3 will also come. I didn't notice that. Yeah. So you all have the answers. You can take the screenshot. You have the link. Try to run these programs and see if they are working fine or not.
Madam, 1 second. So the last three will be the root 3 or the
Root
extreme.
3.
Okay, okay, got it. Unclear now.
Yeah, now the size function. Size is nothing but the you have to tell me the number of nodes present in the tree. Okay. So can you write a function which can tell me this? Does anyone has an idea? Okay. Okay, Bhuvnesh, you can tell me. Yeah, that's right. If you all would have noticed, these traversals are nothing but they are covering your entire tree, right? So basically, like when you go to the left hand side, it is covering all the left hand side nodes. Right hand side, it is covering all the right hand side nodes, and root at the top is a +1 condition over there. So if I add all the nodes which are traversed on the left hand side, if I add all the nodes which are traversed on the right hand side and add 1 to it, I'm gonna get my size. Is it clear? So you can apply any traversal. I can write here that my size is gonna be, I'll directly write a return function, which will be like size of, it will be root dot left plus size of root dot right. I am using nothing but you can say it's a kind of post order, first left, then right, and then the data. By any chance you get null. So if root is equal null at any point, return 0. Clear, everyone? Okay. Next question in this is, you have been given a tree and you have to find the max value in the tree. Like whatever is the max value in the tree, you need to return it. You will be given the root node. Can you do it on your own? Should I give you like 2 minutes of time to resolve this? Okay, take the time. Is anyone done yet?
And logic is clear to me.
Okay.
So I'll create a temporary variable called as max value and assign root dot data to it.
Okay.
And then traverse to the left and keeping a check that if that max value is smaller than the data, the root of data, then assign it to them. And then same way traverse to the right. If the value is more than the data, then assign the max value to it, then return the max value.
Whatever you have said is right. So it's just that why to include an extra maximum variable? Okay. Like it's simple. Either you are gonna get your maximum on the left hand side or on the right hand side, or it can be the root itself, right? Like
Yeah.
can it be anything opposite to what I said?
No, no.
No. So you can simply return here max function. You can use mat.max. You can write here max v of root.data. Sorry. Root.left max v of root.right. I am not writing it in like ways of Java. I'm just simply writing it that you have to find the maximum of amongst all these three. So I hope you can like frame it in the form of Java format. And that's it. Whatever will be the maximum amongst it, that will be returned. Base condition, if at any point root is equal null. What should we do in that case?
Return 0.
Are you sure? You should return, like by any chance your binary tree contains negative values, then in that case, if you find out the max and you return 0 from here, you are going to get 0. So try to return the min value, integer.min value. Kishan, if I would have returned here root.data, then it would have caused you null pointer exception. Clear? Correct. So this part, anyone having any problem? How to find the maximum value? Okay, if you are good, then we will do our height function. Now, your task is to find the height of a tree. So you will be given the root node and you need to return the height of a tree. Will you guys like to try to do it on your own first? Okay. I'm giving you 2 to 3 minutes of time. Try to do it, else I will start to explain.
I wrote a pseudo code for this.
Fine. So for the height, as I told you, either your like the leaf node, which is the farthest, will be on the left hand side, or it will be on the right hand side. Okay. So you have to know like which one is the farthest. For that, you can write here return math.max, and here it will be height of the left subtree, which will be nothing but root.left, height of root.left, comma, height of the right subtree, it will be root.right. Clear? Along with that, you have to add
Add +1 to it.
correct. So +1 for the root. And that's it. What will be the base condition for this?
Root is not equal to null.
Just give me a minute. Yes, so now the base condition for this, if root is equal null, okay, so 0, base case. Now we will try to observe it little closely. So if I have a tree, let's suppose this, what is its height? Manually calculate me and tell me. 4, right? If you will try to calculate it from here, let's suppose I am writing if root is equal null, then it's gonna return 0, right? So when you will call it from this root, it is gonna call the height root.left function, which will go to left. Again, it's gonna go to left. I'm just making recursive calls. It's gonna go to left. Here also, it's gonna go to left. At the end, when it will be null, it's gonna return 0. So for height root.left, it got the value as 0 as of now, right? Are you able to follow? Yes. For height root dot right, since it know that like there is no right side over here as well. For here there is no left, there is no right. So again for this 0 will come, and overall the height for this particular node is going to come as 1. Yes or no? Yes. Is it correct? The height of this specific node should be 1, is it?
No, we have to keep a counter and then add +1 every
No,
time.
+1 is getting added. It's not a problem. My question is, this particular node that we have got the answer for this, okay, for this node we have got 1. Is it right?
No.
No, right?
Yeah.
For this particular node, if I ask you what should be the height, then what is it?
1.
1. So for this, it should come as 0. For this, it should come as 1, right?
Yeah.
So the thing is, whatever our code is doing, it is very similar to our size function or maximum function, right? It is similar to that, right? So basically it is calculating all the nodes, but in the height function, you need to calculate edges, and always edges are -1, like -1 to the given number of nodes. I'm talking about in a tree. Okay. Are you able to follow this? So when here root is equal null is coming, you should not return 0. Instead of that, you should return -1. Clear now? If anyone is confused about it, you can ping me right now, or you can tell me your confusion right now. It will be better. Okay. What if root is null? Then it is going to return -1. So you can handle that situation at the runtime, right? Like if root is equal null, like specifically in that case, you can return 0. Otherwise, you can apply this height function. Okay. And 1 second, like why it should be 0 if root is null? If there exists no tree, then should the height be 0 or should the height be -1 only?
It should be 0.
Why it should be 0? Like there exists no tree, right? You don't have a tree. So why its height comes into picture?
So it is an edge. Like if there is one root.
See, height is saying that like 0 is also saying height is not there. But you have to represent your root node as well, right? That if there is only one root node in your tree, then its height is 0.
Yeah.
Are you getting me? Yes.
Yeah.
So you need to distinguish between root node and when the root node is not there.
Correct.
So if root node is there, it should be 0. And if root node is null, let's suppose, then it should be -1. Clear?
So I'm just thinking that if there is just one root, it'll go in, then root dot left would be null, and then root dot right would be null, and it will be just +1.
I'm not getting you.
So 1 second. If I follow this logic in this piece of code, and I have just one element, it will go and then go into this block. Root is not equal to null. That first two line will be ignored, and then it will go to math.max. and then it will try to pick the value between left and right, both will return null. So math.max will return me 0 plus 1. So it will return me 1, which is incorrect. So,
Sorry.
huh? So supposing there is only one element,
Yeah,
and
supposing there is only one element.
then this return statement will return me 1, not 0.
No, it's gonna return you 0 only, right? See, what's gonna happen if there is only one node, okay?
Yeah.
Then it will go to the left. Is there any left?
No.
Is there any right?
No.
No. When left is not there, what is it is gonna return -1, right? When root is equal null, that means the left is equal null, it is gonna return -1.
Yeah.
Same goes with the right, it is gonna return -1.
Yeah.
Math.max of -1 and -1 is gonna give you -1.
Now I'm clear. Yeah.
Clear?
Then it will be 0.
Yeah.
Okay.
Okay. And then next function is the depth function. Okay. But this function, you don't need to find the depth. Rather, you need to do a little alterations in your node class. Okay. You will be given here, like I'll change the function name also. It will be fill depth. Okay. Here it is node root. You will be given the root node, and you need to fill the depth of all the nodes in a tree. Like let's suppose I'm giving you a tree. So the depth of root should be 0. So this particular node should have depth as 1. This should have depth as 1. This should have depth as 2. This should have depth as 3. So you need to add in the node class. That is, in the node class so far, if you have seen, you only have data, you have left, you have right, correct? So you can add here a depth variable, and as you are proceeding in your function, one by one, you should fill the depth of every node. Clear? Am I clear to everyone? Okay. So this particular function, I'm not going to explain right now. I want you all to explore it on your own and then come to me and then we will do it. Clear?
Ma'am, fill depth should return int, no? Mm,
No, it's void because you only need to fill it. Okay, like if I like try to access the depth of the root, I should get its depth. If I try to access the depth of any other node, I should get its respective depth. I need not return anything. I'm just filling the depths here. Clear?
okay. Yeah, got it.
Yes. So this is one question. Another is you have been given a binary tree. Let's suppose this 3 minus 1, 8. Okay, this is your binary tree, let's suppose. So you have to do its level order traversal. Level order traversals in the sense you first need to traverse this first level and print 3. Then you need to change your line because first level is done. Or for the second level, what you need to print -1 and 8. Now your second level is done. You need to print third level. So change line again. So here it will be 7, 6, and 5. Then it's gonna be 6, 8, 9, 17, -5, and 6. Again, this particular level is done. You're gonna take another level, -1 and 7. Okay, next level, 3. The next level, it's gonna be 2 and 4 together. So this is how your output should look like for a level order traverse. Clear? So this is one question which I want you guys to explore, think, brainstorm, and then come with any kind of like confusions or anything which you are able to figure it out. Like, I'm not telling you to find the solution, but at least do the brainstorming. Clear, guys? Okay, then. So these are the 2 questions you need to do today. And then we will discuss, like, obviously, if you're not able to do these, we will discuss these in tomorrow's class. Okay. And yeah, sorry for joining late today because there was some network disturbance in my area. I was not able to connect to the class. So yeah, from tomorrow I will be on time. You can use any kind of data structure you know, and you think like it's gonna give me the answer. You can use it. Solution to the linked list problem. Okay, I'll give that. I'll give that tomorrow. Okay.
Okay, madam, when I'm printing this, then I should be also putting against each number the level of the depth, like
No, no, not like the depth function. It is. You're talking about the level order, right?
yeah, level order. So each level would be in a new line. Is that what you want?
Yeah, that is the output which I want.
Okay, got it. Thank you.
Clear?
Mm.
Okay, then. Okay. Okay, Bhuvnesh, it's not an issue. If you are going through the videos, it's okay. So thank you guys for attending the session today. We'll continue tomorrow. Bye-bye.